considering its release by NASA in 1977, Voyager 1 has been traveling through space for 45 years and has finally reached the brink of our solar system. This has been long expected, but contrary to what scientists have always believed, the space probe just found something really surprising on the so-called fringe of our solar system, leaving everyone in awe with more questions than answers. What did Voyager 1 discover? Join us as we unpack Voyager 1's improbable discovery after 45 years in space. During its interstellar journey, the Voyager probes hit a significant milestone when they reached a part of space called the heliopause, which is the boundary separating the solar influence from the vast expanse of interstellar space. Now, bear in mind that the exact location of this boundary had long been a subject of debate, but thanks to the projections of astronomer Bill G. in 1993, it was estimated to lie between 116 and 177 astronomical units, AU. Each AU equivalent to the distance between Earth and the Sun. G's estimations were proven correct when Voyager 1 reached the heliopause approximately 2 decades later, detecting the expected rise in plasma density. Here's where the intriguing puzzle emerged. Despite the increase in plasma density observed by Voyager 1, there was no significant change in the ambient magnetic field direction. This was unexpected, as the transition from an area where the magnetic field originated from the Sun to one where it came from other stars should have caused a notable shift. However, no such shift was witnessed. Scientists initially thought Voyager 1 might be the issue, but Voyager 2 added another layer of mystery to the puzzle. When it reached the heliopause at similar distances, it too failed to detect any magnetic field changes. These unexpected observations pose challenges to theoretical models depicting the behavior of the heliosphere and its interaction with the interstellar environment. The prediction that there was synchronization between the heliosphere and the Sun's 11 to 12-year cycle did not align with the data gathered by the Voyager probes. Additionally, the solar wind, which fluctuates with the Sun cycle, was at its most powerful when Voyager 2 arrived at the heliopause, suggesting that the expected position of the boundary might be further out than previously thought. But it's not all discouraging. Thanks to the data gathered by the Voyager probes, theoretical models have been refined. Due to the Voyager discovery, scientists now believe that our Sun has transitioned from a hot ionized region to a partially ionized phase of the galaxy, possibly triggered by nearby supernovae. These ancient stars heated the surrounding area and stripped electrons from nearby atoms. The boundary between these regions can be likened to a turbulent beach, characterized by mixed magnetic fields and small-scale variations near the heliopause, while negligible changes occur on larger scales. As for what will become of the Voyager probes, their paths diverged, with Voyager 1 heading towards the constellation of Ophiuchus and Voyager 2 making its way to the constellation of Cetus. While some scientists predict the probes may end their mission in 2030, they could potentially persist for millions of years, outlasting our species. Perhaps someday they may encounter other star systems, carrying with them the golden record, a time capsule of humanity. However, the Voyagers didn't simply venture into outer space on their own. They were launched with missions that were closely tied to the future of humanity's exploration into the deep reaches of the cosmos. After America lost the robotic race to the moon against the Soviet Union in the 1950s, the focus of space exploration shifted. While the moon and space dominance were still recovering, the attention turned to a more popular and well-funded manned program. During that time, unmanned exploration took a backseat to supportive roles, with missions like Ranger and Lunar Orbiter paving the way for future Apollo missions. But the idea of exploring other planets captured the imagination of many, coming in second only to the excitement surrounding the Apollo missions themselves. Exploration programs naturally gravitated toward the next step, exploring other planets. Some argue that robotic missions were more scientifically pure in design and purpose, downplaying the scientific achievements of manned missions, but it was the prospect of capturing images of the planets that truly resonated with people. The dream began to become reality on September 5, 1977, when an extraordinary spacecraft was launched from Cape Canaveral, Florida, renowned for its testing of missiles and space probes. This event marked the beginning of a great journey as Voyager 1 and Voyager 2, twin spacecraft, were launched into space. Voyager 1 wasn't launched first because, just 15 days earlier, its twin Voyager 2 had embarked on the same cosmic adventure. Their mission was to explore Jupiter and Saturn, the gas giants of our solar system, along with their unique moons. But no one expected these intrepid explorers to exceed their initial goals and venture to the farthest corners of the celestial horizon. The Voyager twins were equipped with cutting-edge technology, even by the standards of their time. From their engines to their propellers and antennas, everything was meticulously designed for durability. NASA drew inspiration from the Mariner spacecraft but made some interesting modifications. The accomplishments of these Voyager probes were nothing short of spectacular. Over 40 years ago, their initial observations of Jupiter and Saturn's moons left researchers astonished as they watched their preconceived notions about these distant worlds shatter. Previously, it was thought that these foreign moons were desolate and crater-marked like our own moon, but scientists later discovered them to be teeming with geological activity. Voyager 2 in particular achieved several remarkable milestones during its journey. In 1986, it became the first spacecraft to fly by Uranus. Just 3 years later, it conducted a flyby of Neptune. Voyager 2 remains the only spacecraft to have embarked on such a course to this day. As these resilient spacecraft continue their unique journey, NASA has taken steps to extend their operational lifespans. Over the past few years, non-essential components and heaters have been deactivated to conserve energy for the probes. This strategic move ensures that the Voyagers can continue to function properly into the next decade, with the projected end of their mission set for 2030. The results of the Voyager missions evoke bittersweet emotions for the scientists and engineers who have played crucial roles in this extraordinary adventure since its inception. Their unwavering dedication and tireless efforts have propelled the mission far beyond its initial expectations. The data transmitted by the Voyagers has yielded invaluable insights, driving countless scientific discoveries and fueling the imaginations of researchers and space enthusiasts across generations. It's important to note that Voyager 1 and Voyager 2 were not your typical spacecraft. They were meticulously designed to be robust systems with a rotation rate more than 15 times slower than the hour hand of a clock. This deliberate design choice minimized any blurring of images and data as the spacecraft zoomed through space. Even before their encounters with the outer planets, the spacecraft began beaming back images of Jupiter while still several months away from the planet. These early snapshots, showcasing the swirling clouds and the iconic Great Red Spot, brought immense satisfaction to the people at NASA's Jet Propulsion Laboratory. However, it was the discovery of active volcanoes on Jupiter's moon Io that stole the show. Io is slightly larger than Earth's moon, but what made it exceptional was its volcanic activity, surpassing any other body in the entire solar system. The spacecraft detected unusual signals emanating from Io, and the vivid images they captured showcased these findings. These snapshots revealed towering volcanic plumes on a surface marked by the ejection of volcanic material. One of Io's prominent volcanoes, Pele, has erupted 30 times higher than Mount Everest, covering an area nearly as large as France. In total, the Voyager spacecraft snapped over 33,000 images of Jupiter and its moons, revealing the planet's stunning beauty and the diverse range of the Jovian moonscapes. Before delving into their latest mind-boggling discovery, let's not forget the twin Voyagers' breathtaking findings since their launch. One of the most spectacular revelations was the discovery of Jupiter's rings, which, though faint, added an extra layer of intrigue to the gas giant. Voyager 2 unveiled the icy shell of Europa, one of Jupiter's 53 moons, believed to be over 6 miles thick. These findings challenged our previous assumptions about these distant celestial bodies and sparked further investigations into the potential habitability of icy moons. As the Voyagers bid farewell to Jupiter, they received a gravity assist that gave them a crucial boost towards Saturn. Without this nifty push, they wouldn't have escaped the sun's gravitational pull and ventured deeper into space. Voyager 1 and Voyager 2 then embarked on separate trajectories, each heading toward new frontiers. Voyager 1 embarked on a trajectory that brought it close to Saturn's moon Titan, enveloped in an orange, hazy atmosphere. The mysteries surrounding this moon piqued the interest of scientists, leading to more studies on its complex chemistry. Voyager 2, on the other hand, embarked on a series of thrilling adventures that took it to the outermost planets of our cosmic neighborhood. In 1986, it made history with a flyby of Uranus, where it discovered 10 previously unknown moons, increasing the planet's moon count. 3 years later, Voyager 2 reached Neptune, unveiling the extraordinary features of this distant ice giant. During its encounter with Neptune, Voyager 2 recorded wind speeds of up to 1,000 miles per hour, making it the fastest wind ever observed on a planet within our solar system. As the spacecraft zoomed within 2,180 miles of Neptune's azure methane atmosphere, it provided unprecedented insights into this distant world. Neptune's largest moon, Triton, turned out to be one of the coldest spots in our solar system. The discoveries made by the Voyager probes have revolutionized our understanding of the outer planets and their moons, opening up new avenues for exploration and sparking excitement for future missions. Moving beyond Jupiter, the Voyagers ventured towards Saturn, where they discovered the complex ring system and the diverse moons orbiting the planet. Voyager 1 provided close-up images of Saturn's largest moon, Titan, revealing its dense nitrogen-rich atmosphere and hydrocarbon lakes. Voyager 2 continued its journey towards Uranus and Neptune, becoming the first spacecraft to fly by these distant ice giants. The mission to Uranus uncovered previously unknown moons and unusual magnetic field interactions, while the encounter with Neptune yielded insights into its dynamic atmosphere and its moon Triton, with its geysers of nitrogen. Perhaps the most significant milestone of the Voyager missions was their crossing into interstellar space. Voyager 1 achieved this historic feat in 2012, becoming the first human-made object to enter the space between the stars. Voyager 2 followed suit in 2018, further expanding our understanding of the heliosphere and the boundary where our sun's influence diminishes against the backdrop of the Milky Way galaxy. The data transmitted by the Voyager probes continues to shape our knowledge of the heliosphere, interstellar medium, and cosmic radiation environment. Their observations have challenged existing theories, provided new insights into planetary atmospheres, and sparked further exploration into the potential habitability of distant moons. Beyond their scientific contributions, the Voyager missions have inspired generations with their resilience, curiosity, and the spirit of exploration. The golden record aboard both spacecraft encapsulates the diversity and creativity of human civilization, serving as a message to any extraterrestrial intelligence that may encounter the probes in the distant future. Looking ahead, the Voyagers continue their silent journey through the vastness of space, carrying with them humanity's hopes and aspirations for discovery. As they traverse the darkness between the stars, their instruments continue to operate, sending back valuable data that will guide future missions and deepen our understanding of the universe. In conclusion, the Voyager missions represent a testament to human ingenuity, perseverance, and the insatiable quest for knowledge. They have not only expanded our cosmic perspective, but also reminded us of the boundless possibilities that await us in the uncharted territories of space. As we celebrate their achievements, we look forward to the next frontier of space exploration, where new spacecraft will build upon the legacy of the Voyagers and continue to push the boundaries of human exploration farther into the cosmos.